Afternoon or evening. How are you doing today? Welcome back to Mr. Morrow's Honors Geometry class. Today we're going to continue with similarity. And sorry about that. Today we're going to continue with similarity. And polygons are similar if they have three things. Okay? Very important. Please remember, similar is not the same as congruent. Let's just go over that real quick before I do anything else. Congruent, same side, same size, same angles. Okay, same size, same angles, same shape. Polygons, they have the same, that are similar, they have the same shape for sure, 100%. However, they're congruent corresponding angles. They have congruent corresponding angles. Now this is the thing. They're different size. Okay? They have proportional corresponding sides. So I should really, to be more accurate, I should have said here, they have the same shape, but different size. Okay? They have a different size. Their corresponding angles are congruent, and the corresponding sides are proportional. So right here we have two similar triangles. They're both triangles, so they are the same shape. Okay? The angles, let's call this a 30, a 90, and a 60. Let's go a 30, 90, and a 60. Hopefully you guys remember what corresponding means. A has to correspond with D. So that's why A and D are both 30. B corresponds with E. That's why B and E are both 90. And C corresponds with F. That's why C and F are both 60. Don't ever go by the figure. Always go by the actual letters of the polygon. In this case, the triangle. Okay, so we have number one, same shape, different size. We have number two, congruent corresponding angles. Awesome. Now number three, how do you do this proportional corresponding side thing? Okay, let's remember how we do corresponding sides as well, gentlemen. AB corresponds with DE, correct? All right. Well, AB is 8, correct? Right? And what is DE? 4. So that's 8 to 4. So this is a 2 to 1 ratio. Triangle ABC is twice as large as triangle DEF. This corresponding proportionality has to be constant throughout the whole entire triangle. So BC corresponds with EF. What is the size of BC, gentlemen? And EF? That's also 2 to 1. And AC has to correspond with DF. What is the size of AC, gentlemen? And what is the size of DF, gentlemen? So this has a 2 to 1 ratio. Remember we talked about ratios last time. 2 to 1 if you're going large to small. Or if you went from DEF to ABC, you could have said it's got a 1 to 2 ratio. So if you know that I have a 1 to 2 ratio, I'm going from small to large, and I tell you that DF is 6, well, if it's 1 to 2, then you got to multiply by 2 to get to 12. If I tell you, though, it's a 2 to 1, I'm going from large to small, and I tell you AC is 12, you got to divide by 2, and the smaller side of the smaller triangle would be 6. Yes, sir. This squiggly line, thank you so much. I appreciate that, sir. That means similar. Yes, sir. It's the congruency without the equal. Thank you, son. That was a very good question, my brother. Thank you. May I continue, gentlemen? Okay. When we're talking about similarity, there is something called a dilation and a reduction. And a dilation, there we go, is when you increase the size by multiplication. And a reduction is when you decrease the size by division. They're opposites. Think about when you go to the eye doctor and they dilate your pupils. They put in a chemical, I don't know what it is, but it enlarges your pupil. Okay, almost to the whole entire size of your actual iris, so they can see the pupil better. That's what dilate means. It expands it. Yeah, when you go to the eye doctor, they put those drops in there. It expands your pupils. Okay, so a dilation is increasing size by multiplication. If I have a dilation factor of 5 from one triangle, for example, to another triangle, I got to multiply all the sides of that original triangle by 5 to get to my dilated new triangle. If I have a reduction, I'm decreasing the size by division. Okay? So, let's look at example 1. Example 1, you see this nice little drawing here. And unfortunately, I didn't write down the question, so let me write down, let me see what the question asks. I apologize about that. I should have written that down. Okay. It says a pinhole camera, this is back in the old days, produces a reduced image of a candle. The size of the image is proportional to the distance of the candle of the camera. Given the measurements shown in the diagram that I did write down here for you, find the height of the camera. Okay, so let's think about this here, guys. You're looking of the candle, not the camera. You're looking for this height right here, okay? Through the pinhole, you see this candle, and if you notice, I reversed it because it's upside down. When you went through a pinhole camera, what you see is the image upside down. It's kind of pretty cool. So the size of the pinhole camera candle is 2 centimeters, okay? The distance from the candle to the pinhole, which is right here, is 5 centimeters. The distance from the pinhole to the actual candle is 20 centimeters. I want to find the height of the actual candle. 2 ways to set this up. Why are there 2 ways? Because of the means extremes ratios theorem. There's several ways to set up this proportion. The way I like to do it, I say height of the original candle, the large value, to 20 equals height of the small to 5. I personally like to keep things the large with the large and the small with the small. But candle height has to go to candle height, and distance from pinhole has to go to distance from pinhole. So when you cross multiply here, I have 5h equals 40, so height would be 8 centimeters tall. However, that's not the only way to skin this cat. There is the means extremes ratios theorem. So what I could do is I could say, hey, wait a second. Let's go height to 2. So in this case, I'm taking height to the height of the candle in the camera equals 20 to 5. Distance of the large, distance of the small. So I went large height to small height equals large distance to small distance. When you cross multiply, you get the same value. What do I like better? Me, I like this one. But to be honest with you, who cares what I like? You gotta figure out what you like best, what works for you. Okay? My brain works differently than your brain. But luckily we have this ability to change them up to suit your needs. But notice, there has to be a correspondence here. My correspondence was the values of all the large. Large height to large distance equals small height to small distance. You can't just mix and match anything. There has to be a unity. In the green, I said large height to small height equals large distance to small distance. Okay? Does that make sense? Okay. Number 2. Here, number 2, if I tell you that triangle MCN in blue here is a dilation of triangle MED with an enlargement ratio, or they could say a dilation ratio, of 2 to 1 for each pair of corresponding sides, find the length of the sides of MCN. Okay. Bless you, son. I want to find the length of the sides of MCN. Well, 2 of these lengths are going to be very, 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 very simple. What is the height of ME, the red guy, the small guy? It's 4 units, right? So if there's a dilation of 2 to 1, what is the height of MC, the large? 8. Very good. You with me here? Okay. What is the distance of MD, the small red triangle? 3. So what is the distance of MN if there's a dilation of 2? 6. That's Mickey Mouse, right? Now, here's a question because I'm getting my classes mixed up with algebra and you guys. We have not learned the Pythagorean theorem yet, correct? We have not in this class, right? Okay. Well, I know you learned it last year. If you wanted to, the easy way to do this is a squared plus b squared equals c squared. But let me just give you the real way to do this. Go ahead and find, oh, I should have done that in red. Find this distance with the distance formula, which we have done. x2 minus x1 squared plus y2 minus y1 squared. So that is the square root of 0 plus 3, so that's 3 squared, plus 4 plus 0, which is 4 squared. That's 9, plus 16 is 25. Square root of 25 is 5. So this guy is 5, ED. What would CN be? If it's a 2 to 1 dilation, 10. You do not have to do it twice. If you know the dilation, everything will extend by 2. Yes, sir. Absolutely, I'm very proud of you. You could use the Pythagorean triples. We're going to get to that soon in another chapter, but yes, you could. If you knew that was a 3, 4, 5 right off the bat, you could just double it for sure. Beautiful. Thank you, son. Very awesome question you just had there. Okay, how about here? I say to you that ABCD is similar to EFGH. They are similar. So you know that their sides their corresponding sides are proportional. I want to find FG, I'll call it X. I want to find GH, I'll call it Y. And I want to find EH, I'll call it Z. Okay? Very simple here, guys. What side does AB correspond to? Okay, no, you're going by the figure. It's EF. So, what side does AD correspond to, gentlemen? HE. Okay, so check it out. This is the way I do it. There are several ways to do this. I go from one triangle to another. I say that 6 to 7 has to equal 9 to Z. Now here, what you have to make sure of is that the 6 and the 9 are corresponding sides, and the 7 and the Z are corresponding sides. Some people like to do it like this. No, I'd rather go 6 to 9 because they're corresponding. It makes more sense to me, moral. And then I like to go 7 to Z. Hey, guess what? No worries. I don't care. And I don't mean that sarcastically. That is up to you Me, the way my brain works, I personally like this one. But again, no disrespect to myself either. Who cares what I like? It's a matter of what makes sense to you. So let's cross multiply. That is 6z equals 63. So z will equal 10 and a half, 10.5. Correct? Yeah. So this guy here, HG, is 10.5. Now let's find x. Okay. Me again, I'm gonna go AB corresponds to FE. I'm gonna use that guy again. Why do I use that guy and not the 10.5? What if I made a calculation error and I used the 10.5? Now I'm really out of luck, aren't I? Now everything is gonna be wrong. So I'm gonna go 6, 2, and this time I'm gonna go BC. And BC corresponds with FG. Good job. So I'm going to go 6 to 4 equals 9 to x. Cross multiply. 6x equals 36. So x equals 6. And last but not least, this time I'm going to go. Actually, no, let me stick to my 6 and my 9. I'm going to go AB to DC. Okay? DC corresponds with HG. So 6 to 3 equals 9 to Y. Cross multiply. 6Y equals 27. Y will equal 4.5. Does that make sense, boys? And again, it really does not matter to me how you set up your proportions. You with me here? Okay. Similarity corresponding sides theorem. The ratio of the perimeters of two similar polygons equals the ratio of any pair of corresponding sides. So, again, the ratio of the perimeters of two similar polygons will equal the ratio of any pair of corresponding sides, if they're similar. So first things first here. Is ABC similar to DEF? Yes, because we have 6, 3, so 3 times 6 is times 2 is 6. 5 times 2 is 10. 4 times 2 is 8, so that works. Corresponding angles are congruent. It is the same shape, so yes, absolutely, it is similar. Now, if that's the case, what are the ratio of sides here? If I'm going from large to small, 2 to 1, correct? If I'm going from small to large, 1 to 2. So what's the ratio of the perimeters? 2 to 1 or 1 to 2. I'll prove it. Let's do this guy, and actually, wait, let me stay consistent here. Here in black, okay, here in black. What's the perimeter of that triangle? 24. What is the perimeter of the small triangle here? 12. So going from large to small, isn't that 2 to 1? If I'm going small to large, isn't that 1 to 2? Feel me here, guys? Promise? So on SATs, they love to do that. They'll give you two triangles or two triangles, and they'll say, okay, what is the ratio of their perimeters? And people stress out. Just find the ratio of one set of corresponding sides. That's the ratio of the perimeters. Done. Period. Gone. Bye-bye. It's not an if, and, or maybe. It's a for sure 100%. Does that make sense? Yes, sir, my brother. Oh, it could be 4 to 1. It could be 3.2 to 1. Thank you, sir. It could be 6 to 9 or 6 to 7. Doesn't always have to be 2 to 1. Thank you. Okay, let's go and pause real quick. All right, guys. Let's look at the last few examples here. Shh, shh, shh. Come on, guys. They said triangle JHK is similar to triangle POM. Angle H is 90. I've already labeled that for you. Angle J is 40. I've already labeled that for you. Angle M is x plus 5. That's been labeled. And angle O is 1/2 y, which is already labeled. I went ahead and was nice. Since you have a 90 and a 40, angle K has to be 50 degrees. Okay? So they want to find the value of x and y. Well, my brothers, isn't angle POM 90 degrees? So how would I find y? Half of y equals 90 times 2 to both sides. Y equals 180. Now, before you get all crazy on me, I did not say that angle POM equals 180. No. Y equals 180. POM is 90 because 180 times a half is 90. Okay? Now, how would I find angle M? Huh, guys? Who does angle M correspond to? Angle K. What does angle K equal? So what does x plus 5 equal? Very good. So subtract 5 to both sides. X equals 45. Basic algebra here, gentlemen. Basic algebra. Does that make sense? You can only know this if they are similar, or if you were to say they were congruent, because the angles are congruent as well. But if you don't know what similar is, you don't know that the corresponding angles are congruent, you're out of luck, Chuck. All right? Next, triangle BAT, which is this large triangle here, BAT, is similar to triangle DOT, which is right there. Okay? I want to find the value of x, which is segment OA. I'm sorry about that. I should have put a segment symbol. Okay, I want to find x. Well, this is simple. Isn't 15 the height of my blue triangle to 9 the base of it? Well, doesn't that have to equal the height of BAT? And what's the height of BAT? Not 15. It's not x either, guys. The height of BAT goes from here to here. It's x plus 15, guys. Isn't this part of BAT 15? Then from here to here, isn't that x? Okay. And what is the base of BAT? 12. BAT is right here, guys. BAT, bat. So let's go ahead and cross multiply. 150 times 15 times 12 is 180. That equals 9x plus 9 times 15. That's 135. Correct? Yeah. Subtract 135 to both sides. So that's 45 equals 9x. Divide both sides by 9. X equals 5. Okay, very simple. All right. Now, last but not least, in the diagram, segments PA, PB, and PC are drawn to the vertices of triangle ABC. Okay? So segments PA, PB, oh, actually, it was too far for PB. PB and PC are drawn to the vertices of triangle ABC from an external point P, then extended to 3 times their original lengths to points A prime, B prime, and C prime. Okay? Find, whoa, but I didn't put any values here. That's going to be very difficult. That's my bad. So if AC is 15 and CB is 10 and AB is 12, I want to find the sides of A prime, B prime, C prime. Well, this is simple, guys. This is a dilation. If AC is 15 and I have done a 3 times dilation, what is A prime, C prime? 45. If CB is 10, what is C prime, B prime if I did a 3 times dilation? And if AB is 12, what is A prime, B prime if I did a 3 times dilation? 36. And that's it. Ding dong, the witch is done. All right, guys. Thank you very much. Hope you learned a lot. And have a wonderful day, y'all.